Okay, so let's work on a problem in which we're working with the standard normal random variable z. When we talk about standard normal, we're always talking about the random variable z, and it is always true that the mean of the standard normal random variable z is a mean is 0, and the standard deviation, sigma, is 1, always. Okay, so the questions that you're going to find in the homework are going to say something like, find the area to the right of z equals some number. I will expect you on the exam to, I will place this blank normal curve here, and I will expect you to shade and label these normal curves on the exams. So the first thing I'm looking for is where the mean is located, and the mean is always in the center. And as I said a minute ago, the mean is always 0 for the standard normal random variable. So now this bottom axis is just like any number line. As you move to the right of 0, the numbers are positive, and as you move to the left of 0, the numbers are negative. So we can guess that 1 is about here, say, so you're maybe looking right about here for 1.62. And remember, these are z values on this scale. So I'm going to draw my line at 1.62 because that's the z value I'm given, and I want to find the area to the right. So I'm going to shade to the right. Now, there's a lot of ways we could ask for this. We could ask for the area. Another equivalent way to ask for this is if we want the probability that z is greater than 1.62. You're going to see it asked that way as well. So either we want the percentage of data to the right of 1.62, the percentage of data greater than z equals 1.62, the probability that z is greater than 1.62. So anytime we want area on a normal curve, we're going to use our calculator function that is normal CDF. What we put in first is the lower bound of the area that we want. This is where the area starts, and it goes to infinity on the right. It will go forever. So my lower bound is 1.62. I don't have an infinity button on the calculator, so what your book suggests, and I like it, is to just put E99, which means 10 to the 99th power. It's just a humongous number. So that's the point. You just want a really, really large number. So again, this is my lower bound. This is my technical upper bound, which is infinity. Here's the mean, and here's the standard deviation, and that is always how we will work these problems with those 4 items in the normal CDF. So we will go to our calculator under VARs, and we find number 2 is normal CDF. I'm going to put these values in. And I get an area or a probability of 0.0526. And get in the habit of using 4 decimal places for these values, because that's what I'm going to expect. Okay, so let's just quickly go on to the other ones. Again, I want to see the mean in the middle. This is part B. The mean is 0. I'm going to once again place my z equals 1.62, the 0 z values here. I'm going to shade to the left, and when it says left, I go all the way to the left. And now I know that the area I'm looking for is going to be bigger than 0.5 because I've got more than half the curve shaded. Again, this could be phrased in this way, that we want the probability that z is less than 1.62. We're going to do normal CDF. And now our lower bound, since we're going from a number all the way out here to negative infinity, our lower bound is negative infinity. So we're going to use negative E99, 1.62, and the mean and the standard deviation. And by the way, the default is 0 and 1 for that mean and standard deviation. So if you actually don't put that in, you will get the right answer. You can leave that off. You can leave off the 0 and the 1. Okay, so this gives us an area value of 0.9474. And by the way, these two values, this 0.0526 and 94, those would add to 1 because we're finding, in that case, the whole entire curve. So we could have just taken 1 minus that value. All right, if I want the area between, again, I still want to see the mean in the middle. I want to label my 1.62. 2.75. Remember, these are z-scores. I want the area in between. This is the easiest case of all. I want to have z in between. And by the way, it makes no difference whether I say less than or equal to or greater than or equal to. The actual endpoints are irrelevant here. So whether I include them or not means nothing to my answer. So now my lower bound is 1.62 of my area. My upper bound is 2.75, 0, and 1. And I'm going to get, let's see here, 1.62 to 2.75. That area is 0.0496. So by the way, let me just draw some arrows. This area that I just found is this. This area that I found here is all that shaded, and this 0.0496 is this area right here.